I wanted to start documenting all the 3D printing I do. I figured I might as well show others how I do it, share some tips and tricks, because 3D printing really is pretty amazing. So let's get into this one. So I've been measuring this thing little piece by piece. You see I've got a lot of it already designed and spec'd out. There's a little bit of a tapering to it because it's supposed to hold tension as it pops into place. But what I'm doing is measuring little pieces, building it basically in a 2D modeling scenario. Kind of like if you were to sketch it, you'd be sketching it to scale, and then I'm going to render it to 3D. I'm going to build it out. So I've been measuring little pieces right here. Getting this arc correct isn't too difficult. A lot of it's me eyeballing it. So I measure it here, and then I build some points, and then connect those 2 points with an arc, and I get the thickness of the top that I could measure, and the rest of it falls into place. Let's see, it gives me a nice little arc the way the original part looks. Then I cut in these little tapers, basically do a little measurement to decide how many millimeters the cutout is up, and then I know because it goes all the way over, I just join the line and there's my little cutout for the notch. Super easy, nothing too difficult. One thing that's really a perk with this is I could build it flat and build it up. If you could picture the strength of layer by layer, having it on its side like this builds a lot of strength into it and kind of gives it the spring effect as well. So this type of part really is a perfect build scenario for 3D printing. So this was a project from a friend of mine. Basically had this clip. It's off his Evap system on his Durango. You'd have to buy a whole new hose in order to get the clip, supposedly. He hit me up. I said, sure, let's do it. I was pretty sure I could make it. 3D printing in an engine compartment's not recommended, but this will probably still work just fine anyway. So once I have this initial extrude, the actual height of how thick it needs to be on the base, now there's a little pop-up, a little bit higher portion for like the collar on the back. So I'll measure that and I'll extrude that piece, get its proper height. Once I have that, things are looking good, coming together nicely. There's a little cutout I've got to do here. So on the tips, they have a little bit of an angle because what it needs to do is slide easy into through the little hose clip assembly. And so it is tapered, like I say, and then those little tips, if they're a little bit tapered, it'll help them line up and slide through a little bit more efficiently. Technically I could just sand them down with a piece of sandpaper later, but I might as well build it into it. A lot of times I don't like having overhangs, and I'll modify it later, but for this one I built the little cutouts, and I'll probably still sand it later as well, but it'll make it a little more finished, a little more polished in the end. Now I have this little slanted cutout on this side. Now this one's a little bit tricky. It's hard to fully explain it, but I'm going to try and show you what I'm doing, because what you have is this bevel option within the application that allows you to either round the edge or put a 45-degree angle on it. Now what's nice about the 45-degree angle, because this part tapers, it was easier for me to do it this way than try and do some other sort of method to kind of cut it out and get that angle correctly on that taper. Because if you notice left to right, it's pinched in a little bit at the end, like I've been explaining. The fact that I measure where the taper should go, and then I went 0.001 millimeter in to the part and joined like a little cutout. So basically I'm kind of going to shave a little piece where this angle should go out, and then I can actually click on that edge of that cutout and say bevel it, and then it follows the taper of the actual part, and I get it a lot more precision than I would other ways. Now obviously if I knew how to use the tool I wouldn't have to do this, but like I say, it's a quick way to try and get people that don't know the CAD application but would like to be able to use it to do some of the stuff that you could do with this tool. So if that makes sense, again I cut a little bit of the edge off, and that means when I clicked a little bit of the edge that I've cut out, now it isolates that edge to where I can put a taper just on that portion. And so I kind of just fudge it and I leverage it and I taper it, and you can see that now I've got the little taper in there that I like. At this point everything's looking really solid. There's a little bit of tuning I'll do in the end to kind of clean up some of these edges that need to be tapered. So another little tip here. For this little guy I'm going to do a 0.06 because obviously it's not going to take very long to print. I try not to do a 0.06 on larger scale ones because that usually makes my prints go forever, sometimes for days. So, especially wanting higher quality, a little more strength to it, the 0.06 millimeter will be the selection here. And then what I'll do is I make sure that it lays flat on the plate. Again, I like that it lays flat and it protrudes up, so I don't have any support material underneath it. Just going to build it solid straight away. And I never print just one at a time because it's a little too hot on the nozzle just to repeat layer over layer, and so I like a little cooling in between. So I'm going to make 3 of these even though I only need 1, and I'll get a better quality part out of the whole deal. So it's going to be 3 parts, and the fact that the nozzle has to switch the other parts to kind of do a layer, it's going to allow some cooling on the one next to it, so it will give me a better part in the end. Big thanks from Zen Times 10 for watching. If you like that video, make sure you subscribe. We have future promos and contests coming up. Click that like button and drop us a comment on the way out.